Good day. Problem set number 1. Example 1.10. Calculating heat transfer through conduction. A polystyrene foam icebox has a total area of 0.950 meters square and a walls with an average thickness of 2.50 centimeter. The box contains ice, water, and canned beverage at 0 degrees Celsius. The inside of the box is kept cold by melting ice. How many much ice melts in one day if the ice box is kept in a trunk truck of a car at 35 degrees Celsius? So first, we write the given. Our given here is K, or the which represent as the thermal conductivity, which have 0.010 watt per meter degree Celsius, and our area is 0.950 meter square, and our thickness here is 2.50 centimeter, and we convert it into meters, so we get the 0.0250 meter. So our temperature in colder is 0 degrees Celsius, and our temperature in hotter is 35.0 degrees Celsius. And our time here is 1 day, so we convert 1 day into 24 hours. That we all know that our 24 hours we have 84,400 seconds. So we solve. P is equals to dq over dt equals Ka times Th minus Tc over d. P is represent the power rate. So ato ni butang ang known value, which our thermal conductivity or K is 0.010 watt meter degree Celsius, and our area is 0.950 meter square, and our TH is 35.0 degrees Celsius, and our TC is equal to 0 degree Celsius. Divide thickness, which D is 0.0250 meter. So we get 13.3 watt. To find the Q, we use the equation Q is equals to power rate times time. So we all know that our power rate is 13.3 watts times our time here is a 1 day, or 84,400 seconds. So we get the 1.15 times 10 raised to the power of 6 joule. So to find the heat transferred to melt the ice, we use the equation Q is equals to MLF. So in this equation, we find the mass. So ang formula mo true. So ang formula here will be mass is equals to Q divide LF. So we all know that our Q is 1.15 times 10 raised to the power of 6 joule times our LF here is given with 334 times 10 raised to the power of 3 joule kilogram. So we come up with the answer of 3.44 kilogram. Problem set number 2, example 1.11. Two conductors end to end, a steel rod, an aluminum rod, each of diameter 1.0 cm and length of 25 cm are welded end to end. One end of the steel rod is placed in a large tank of boiling water at 100 degrees Celsius, while the far end of the aluminum rod is placed in a large tank of water at 20 degrees Celsius. The rods are insulated so that no heat escapes from their surface. What is the temperature of the joint, and what is the rate of the heat conduction through this composite rod? So, given our length of the steel is 0.25 meter, and our area is 7.85 times 10 raised to the power of negative 5 meter square, and our thickness of the aluminum is 220 watt meter degree Celsius, and our thickness of the steel is 80 watt meter per degree Celsius, and our temperature in the colder is 20 degrees Celsius, and our temperature hotter is 100 degrees Celsius. So, solution. we use the equation of P power rate of the steel is equals to thickness times area times time divide length. So our thickness of the steel is 80 watt meter degree Celsius times our area is 7.85 times 10 raised to the power of negative 10 meters square, and our T here is 100 degree Celsius minus T divide 0.25 meter. So we get the 0.025 watt degree Celsius times 100 degree Celsius minus T. So and for the aluminum, two, we all know that the thickness of the aluminum is 220 watt meter degree Celsius times 7.85 times 10 raised to the power of negative 5 meter square times T minus 20 degree Celsius divide 0.25. We get the 0.0691 watt degree Celsius times T minus 20 degree Celsius. So, to find the rate of steel, we times 0.0251 watt degree Celsius times 0.0691 watt degree Celsius, which our muna siya tong power rate of aluminum minus 41.3 degrees Celsius. So we get 1.47 watts. Problem set number 3, example 1.12. Calculating the flow of the mass during convection. The average person produces heat of a rate of about 120 watt when at rest. At what rate must water evaporate from the body to get rid of this energy? For simplicity, we assume that evaporation occurs when a person is sitting on the shade and surrounding temperature are the same as skin temperature, eliminating heat transfer by other methods. So in this problem, we use the equation Q is equals to mass times length evaporation. So the energy loss per unit, we divide the equation both side by time. So we can convert the 120 watts into 120 joules per second. So we get the 120 joules per second. We all know that our later evaporation, we see in table 1.4 that our later evaporation is about 2,430 joules per second. So ato na siya ibutang sa equation. So solve, so we get the 296 grams per minute. The last problem set, example 1.13. Calculating the net heat transfer of a person. What is the rate heat transfer by radiation of an unclothed person standing in a dark room whose ambient temperature is 22 degrees Celsius? The person has a normal skin temperature of 33 degrees Celsius and a surface area of 1.50 meters square. The emissivity of skin is 0.97 in the infrared, the part of the spectrum where the radiation takes place. So given is our area is 1.50 meters square, our emissivity of our skin is 0.97, and our standard deviation, we kani nga symbol mo ni pagbasa na mo sa mong math subject is standard deviation. So we get, so our standard deviation is 5.67 times 10 raised to the power of negative 8 joules per second times meter square. So we insert the T2, which muna siya atong temperature object, temperature environment Kelvin that have 295 K. So our T1 is 306 Kelvin, which represent the temperature object Kelvin. So, solution. We use the equation QT time A equals standard deviation E times area times T2 raised to the power of 4 minus T1 raised to the power of 4. So, ating substitute the known value. Muna ito isang division is 5.67 times 10 raised to the power of 8 joules per second times meter square times Kelvin raised to the power of 4 times our emission sensitivity of skin, which 0.97, and our T2 here is 295K raised to the power of 4 minus our T1, which 106K raised to the power of 4. So solve this calculator, so we get the negative 99 joules per second or negative 99 watts. We get negative because clothing slows down both conduction and convection, as ma-mention sa video na ang sanina laylahi og conduction. So like black kusog kay mo conduct ang black sa temperature ug ang white less conductor.